Hello, it's Mike here. This is basically kind of a part two on the series I want to get going on here on some of my thoughts, theories, and ideas. What I have here on this bench is a cylinder. Um, and I'm going to kind of use it to try to point out some ideas and thought processes I've had on the STEAM aspect of my project. I'm going to have to do an overall rundown, which might be a bit of a longer video, of my end game and kind of how I think everything's going to work together. But say for the steamy type guys out there, this is one of my basic thoughts and how my thought process is going. And even for non-steamies, guys that are just kind of figuring out that maybe some of our historical knowledge of steam is still something we could be using today, because it is pretty basic. And one of the first things, I mean, if you want to go to the history, a lot of our very first steam engines were basically operated if the piston was being moved to create a volume in the cylinder on the intake. What they would do is allow steam to go inside, and then when the piston hit the bottom of its stroke, the valve would be closed and they would cool the cylinder, and the steam collapsing would draw the piston back up inside, and then they would repeat that. This was used for a few different things. They weren't a high-speed engine, that's for sure, because especially in the bigger volumes, a lot of times they would use huge pistons to move, say, large volumes of water or something to that effect. And then we came to like a positive pressure steam system where you had a boiler, you boiled water and you had it under huge pressure, and then what you would do is when the piston was at the very bottom of its stroke, you would open a valve and blast steam in, and that would shove the piston forward. As technology came along, they started not just shoving the piston forward from one end, they started using steam in the other end to shove it back under power, so it was going forward and back under pressure. One of my thoughts and how doable it would be, and I think it would be really good in a recycler system, which I'll have to take a moment to explain at some point. If we combined the idea of cooling steam to create a suction and heating steam to create a pressure, and if we just took a single action, if we put pressure here to shove the piston down, and then as the piston goes to come back on the exhaust side, basically, if we had a way to drastically cool that steam, in theory, maybe I'm wrong, but in theory I think we could create a suction. So basically you're creating steam, dropping it back, and you're creating steam and pressure, causing the piston to come out, and then you're going to collapse the steam on the other side back into water, creating a suction. So now you basically have two actions out of one end. You're going to put pressure in to move the piston up, suction to draw it back. Even if it's not overly efficient, it's more efficient than just going one way. And then by doing that, we could create a loop possibly where we only cool the water to just below boiling, and then we just have to bring it back up above to make steam again. So that's how we could make a loop. And then if we did that on both ends of the cylinder, I think we could really have something to work with. And this maybe isn't the exact, this is just a demonstration. And hopefully some of these ideas, if you do stick with me and you got a bit of an open mind, we use some history, some logic, some modern technology, I think there is some very efficient multi-fuel systems that could be made. And the steam idea, I think, would be the key to the overall efficiency. So let me know what you think. Keep watching for the next videos, and hopefully it all makes sense. Thanks.